Okay, we're going to talk about scientific notation, so problems 8 through 11 on your test. It seemed like some of you guys forgot that in scientific notation, the biggest rule is that the base has to be greater than 1, but it also has to be less than 10. So for example, a number like this, 36.9 times 10 to the 5th, this is not in scientific notation because this base is not less than 10. It has to be greater than 1 and less than 10. So in order to change this problem so that it was in scientific notation, I would have to move this decimal over 1, and then I would have to add 1 to my exponent. So I would get 3.69 times 10 to the 6th. All right, so let's work through number 8. So when you look at this problem, like number 8, something that you should notice is that the whole problem is multiplying. So I've got 5 being multiplied times 10 being multiplied with the exponent. This is also multiplication here in the middle, still multiplication in between the 8.1 and the 10, and still multiplication with the exponents. So all we're doing in this problem is multiplying. Because we're multiplying and we have exponents, we can use our exponent properties. So we're going to multiply the things that are the same. We're going to multiply coefficient times coefficient. So 5 times 8.1. 5 times 8.1 is 40.5. And then we're going to multiply the things that have the same base, which are 10 to the negative 12 times 10 to the 15th. This isn't a power to a power, so we're not multiplying the exponents. This is just same base, so we're going to add the exponents, and negative 12 plus 15 is 10 to the 3rd. Now you still have to show, because it's scientific notation, you still have to show multiplication in the middle, and we do show it with the x. So if I wanted to figure out what this number would be in standard notation, I know that I'm taking it to the 3rd power. So I'm going to take this decimal point and I'm going to move it to the right because it's a positive exponent 3 times. 1, 2, 3. And I would fill in zeros where those extra little loops are. Well, I know that this base is not in scientific notation because 40.5 is not less than 10. So I know to get a number less than 10, I have to move my decimal over 1. So my final base is going to be 4.05. Well, to get my final answer, which should go all the way out to here, now how many times am I going to have to move? Well, I'm going to have to move the 3 that I would have had to move originally, but I'm also going to have to move this extra one where I just moved that decimal place. So my final answer should actually be 4.05 times 10. And now instead of to the 3rd, we added one more spot that the decimal has to move. So it should be to the 4th. I was kind of confused on what you guys did with this problem because several of you divided. You actually went through and divided. And I'm not quite sure why, because this problem is only multiplying. It is not a division problem at all. So there's number 8. Now let's go take a look at number 9 and number 10. All right, so we are trying to rewrite number 9 and number 10 in scientific notation. Number 9, most of you guys did pretty well. Those of you that got it wrong just forgot that when you are moving your final answer to become a decimal, really, really small decimal, it means you're going to have a negative exponent because you're dividing by those tens. So if I move my decimal to see where I have a number greater than 1 and less than 10, I'm going to move it once, twice, 3 times, 4 times, 5 times, 6 times. So this is where I have a number, this 3.98, that is greater than 1 and less than 10. And you're going to multiply it times 10 to the, it's 6, you're right, but remember, you want this answer to be one of those really, really small decimals. We're dividing by 10 each time, so it's to the negative 6th. Now number 10, is where I lost a lot of you guys. I think you guys forgot that this is not in scientific notation, and you just went straight into standard notation. But if you read the directions, it says write each number in scientific notation. So what I wanted you to do was I wanted you to figure out how to rewrite this so that the base is greater than 1 and less than 10. So where would I move the decimal to have this number be greater than 1 and less than 10? Well, if you said between 5 and 2, you are correct. So we're going to move the decimal over 1. So our new base is 5.26. I know it's going to be times 10 to some power. What it would have been when I started this problem, right here, I have that it is to the third power. So I know I would have moved to the right 3 times. 1, 2, 3. Well, when I move my spacing over 1, I added in an extra space. Now where this answer needs to move, I would have to move now 1, 2, 3, 4 times. So my exponent is to the 4th. So this is my final answer. All right, let's take a look at number 11. With number 11, it says the national debt in the United States is now near 1.8 times 10 to the $13. There are roughly times 10 to the 8th people in the United States. If the national debt is split between all the people in the United States, how much money would each person pay? Some of you guys were trying to multiply this problem, but think about it, guys. If our classroom had a debt of $1,000 and each person was going to pay, what would we do? We would divide the $1,000 divided by however many kids were in the classroom, and each one would pay their amount. It's the same thing here. Here's my debt. Here's how many people are paying. So to find out how much each person owes, you're going to divide. So let's divide this problem. We're using our exponent rules. We notice that we have coefficient divided by coefficient. So 1.8 divided by 3 is 0.6 times. And then I have 10 to the 13 divided by 10 to the 8th, which becomes 10 to the 5th. A lot of you guys wanted to write out these long numbers and actually go through and like cancel out a whole bunch of zeros, 0, 0, 0 divided by 0, 0, cancel. This is sad to me. It shows me you don't really understand scientific notation and how much easier it's going to make your lives. Now, remember, our final answer has to be greater than 1 and less than 10. So when you look here, is this number greater than 1? It's not. So we know we're going to need to move our decimal point over 1 and get 6 times 10 to the something. Well, let's figure out what we're taking 10 to the 2. So right now it's 10 to the 5th. So that means I take this decimal and I move it to the right 5 times. 1, 2, 3, 4, 5. If I move that decimal to the right 1 time and I make this 10 a whole number, well, now how many times would I have to move the decimal to get my final answer? Now I only have to move it 1, 2, 3, 4 times. So my answer was 6 times 10 to the 4th. If you wrote the answer was 1, 2, 3, 4, $60,000, you're technically not wrong. However, when you have problems in scientific notation, you need to write the answer in scientific notation. The whole point of these problems is saying, do you know how to divide when you have scientific notation? Do you know how to multiply when you have scientific notation? If you're writing out a whole bunch of zeros you should know right off the bat you're doing something wrong. That's not the intention in these problems. So I'm going to give you 2 practice problems that I want you to try on your own. So the first one is 4 times 10 to the 8th. Times, oh goodness. Okay, this isn't working, so we're going to go down a line. 4 times 10 to the 8th times 0.2 times 10 to the 3rd. The second problem is 3.6 times 10 to the 9th divided by 9 times 10 to the 4th. So I want you to try those 2 problems. Pause the video and then come back once you have answers. right, so hopefully you've paused and you found your answer. So we're going to go through it now together. On this first one here, we're going to multiply the bases. So we have 4 times 0.2, and 4 times 0.2 is 0.8. So then I have I'm going to have multiply times 10 to the 8th times 10 to the 3rd. These have the same base. They're both 10, so I can add the exponent. It becomes 10 to the 11th. Now, I noticed that 0.8 is not greater than 1, so I know that I'm going to have to do some changing here. In order to do that, let's figure out how many times I would currently move my decimal point to get the right answer. Well, I would move it 11 times, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I change my base, instead of being 0.8, I'm now going to change it to being just 8. How many spaces have I taken away from my final answer? Well, I've taken 1 away. So now, to get my final answer, I only have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So my final answer for this one should have been 8 times 10 to the 10th. Hopefully you guys got that. Over here where I'm dividing, on this next problem, I'm going to do 3.6 divided by 9, which is 0.4, times, and I've got 10 to the 9th divided by 10 to the 4th, which becomes 10 to the 5th. Again, I noticed that my answer is not in scientific notation because my base is not greater than 1. Currently, I would move my decimal to the right 5 times to get the right answer, or to get standard notation. But I don't want, backtrack. I need to move my decimal over 1 time to get a positive 4 times 10. So that means I'm going to take away one of those decimal points, and my final answer is going to be 4 times 10 to the 4th. Hopefully that helped you guys understand, 1, your mistakes, and 2, what you did, or what you need to be doing, and a little bit more about scientific notation. I forgot to give you the keywords as we were going, so I'm going to give them to you now. So for number 8, your keyword is blues. For number 9 and 10, they only have one keyword. It's Hawaii. And number 11, your keyword is love. All right, hopefully you guys have those down. You've done your corrections, and hopefully you are ready to retake. Let me know if you have any questions or if anything didn't make sense to you. Thanks, guys.